Alaska is known for its dynamic and extreme forces of nature. Temperatures can vary by 170 degrees. Rain can fall up to 200 inches a year. Glaciers and permafrost are melting. Alaska is a place that creates incredible challenges for those who choose to live and build here. Challenges that motivated the Alaska State Home Builders Association to found the Cold Climate Housing Research Center, the first such center in the world.
The building's important because, again, it's validation of what we do in the building business, but it is also owned and operated by a group of people who want all the other builders in the building community across the state of Alaska to have a place to understand how to build in our environment.
Our mission really is to improve the durability, the health, the affordability, the environmentally appropriate aspects of shelter for all circumpolar people. This building has a number of purposes. Not only is it our administrative headquarters for all this field research and disseminating the information from that field research, but what we wanted to build here was a living laboratory in a sense. We wanted to address all the problems that we see in the built environment as much as possible, incorporate it in this building, and keep track of how it was working.
The first challenge builders face in the Arctic is a reliable foundation. Traditionally, they're built either on pilings or below the permafrost layer, both very expensive methods. Cold Climate Housing Research has taken a new approach to building on these unstable soils, with a foundation designed to accommodate expected settling from melting permafrost. First, they pre-consolidated the site by loading it with 1.5 times the building's weight in soil. Then they tested the site to ensure settlement would be minimal.
My drilling crew is performing standard penetration tests to make sure that the thawed soils at the surface will be strong enough to hold the building. In this case, we're predicting somewhere on the order of 8 inches of settlement. The structural engineer has developed a plan to adjust the building, adjust the foundation of the building after the settlement has taken place. This technique will allow the building to be jacked up and shimmed up to compensate for any differential settlement. We've used this approach on residential houses, but never on a heavy research facility of this nature. If this technique is successful, it will significantly reduce the cost of constructing large buildings in the Arctic.
CCHRC incorporated many other innovative approaches during construction.
For instance, we developed a wall system that we feel addresses a lot of issues, not just in a cold place like ours, but also in warm environments.
A conventional wall has insulation and a vapor barrier on the inside of the framed wall. In the center's remote wall, as it's known, the vapor barrier is moved to the outside of that wall and rigid insulation is added to the exterior. This protects the framed wall from cold and moisture, which causes condensation and mold, and increases the structure's ability to retain warmth.
In a lot of our rural villages in Alaska, a lot of rural villages indeed in the circumpolar north, water and wastewater are a big issue. We want to do a system here that could be duplicated in those isolated communities and work. We designed this building to use very little water. We're bringing in potable water for drinking and washing. We're reusing that water in the flush cycle to create black water. Then we're treating in a sewage treatment plant on site that black water to a gray water standard again and reusing it. We're basically trying to close the system. An innovative example of what we did was our heating system here. We've got 3 residential-sized boilers. Those boilers can be configured in a number of different ways, again trying to optimize the efficiency of what we're doing. So along with this 21st century examination of heating systems and high efficiency and all that, we're bringing in 1,000-year-old technology that we know works. What we've got here is a high efficiency masonry stove that burns very, very hot and very, very clean, and then absorbs all that heat and then radiates it out over a 24-hour period. So we get a clean burn, an efficient burn, and we're using old technologies.
So how will CCHRC know whether any of these approaches are working? The building tells you exactly how it's performing by incorporating over 600 sensors that monitor everything from the permafrost beneath the foundation to the walls and roof. Sensors measure outside and inside air temperature, indoor air quality, and the effluent coming out of the chimneys. Above all, these sensors will tell them how efficient their building really is and gives others access to these results on their website in real time.
The bottom line is that we want to bring that information back to builders and back to homeowners who are building houses. That will lead the way then to more energy efficient, more environmentally beneficial buildings in Alaska and in the circumpolar north.
What I wanted to do in this building was, in a way, make it feel like coming home. We also want to involve the outside environment with the inside environment. For instance, our garden roof, outdoor office space. Take your laptop outside and get some work done out there. Be more productive.
There's 3 elements to the landscaping that needed to be addressed. One was the roof garden, another one was the landscaping around the building, and then there was the stormwater catchment pond. How can we build some landscaping in that takes care of the environment, is less impact on the environment, and is also energy efficient? And now it's kind of in vogue in the large cities to put in these roof gardens to reduce the runoff of water, to bring green space into building areas, and to reduce environmental degradation, and then creating a habitat for things such as birds, insects, plants, and people.
In a spirit of partnership, the center was constructed on the University of Alaska Fairbanks campus, giving them an opportunity to collaborate with research scientists there.
So we hope that there's some synergy by having the research lab right here next to the university and do research that's really applied, that's really valuable to builders and homeowners right here in Alaska and around the circumpolar north. We have 5 different basic climate zones, 5 different challenges for builders, and we're trying to develop building techniques that work in all 5 zones. For example, one of the challenges in Ketchikan, where there's so much water down there, people wanted to know, could they collect the water off their roof and drink it? So we developed a project where we came up with a best practices guide to how you collect water off of a roof that's potable. We've looked at the issue of asthma in rural Alaska and how the design of that housing can be improved to affect people who have asthma.
CCHRC wanted to test how their remote wall system performed in wet climates, so they developed and built a mobile test lab.
This mobile test lab allows us to test 9 different wall sections at the same time. And in Juneau, the first set of tests, we tested the remote wall and compared it to 8 conventional walls, and the remote wall outperformed all those walls dramatically.
In collaboration with UAF's Institute of Northern Engineering, CCHRC is working on new formulas for concrete that would maximize the use of local materials and would allow it to set faster and cure in colder temperatures. This would lengthen the building season and reduce costs by not having to heat the area. CCHRC also has an environmental and material lab that will focus on product development and testing. Ultimately, the goal is to test products for a rigorous Certified Alaska Tough label.
Our ideal thing, of course, would be that these things get built right here in Fairbanks. So we think that this research and this product development can actually be an economic development activity as well. One of the things that we're trying to demonstrate here is what's called green building.
CCHRC is part of a national program called LEED, Leadership in Energy and Environmental Design, which is a certification for green buildings. So how is CCHRC energy efficient? By incorporating high insulation walls and windows, alternate sources of energy, collecting rainwater and recycling water. It means using motion-detecting light switches, low-flow faucets, low-volume toilets, and recycled or local materials. And it means creating an indoor quality of life by supplying clean air, using less air-polluting, low VOC products, and allowing workers to open windows and take advantage of natural light.
If you make a more energy efficient building, it may cost you a little bit more for the things you put in it to make it energy efficient, but you're going to save that many times over the course of the life of the building. So this building is designed to lead the way, to show people that we can make buildings more efficient and conserve energy. And this building actually uses 40% of the energy of a conventional building built this size. This building will actually be a net zero energy building. It will produce more energy than it's actually using. It can show the way for people in Alaska and in the nation to use less energy. And these techniques are important not just from saving money, but they're important from a national security point of view. If we don't have to import so much oil, then we don't have to go to war to find oil. If we're not importing so much oil, we're not having such a big impact on the environment. We can actually begin to reduce global warming.
I see the Cold Climate Housing Research Center being the world leader in shelter, in addressing those problems of sustainability. We are trying to develop here in Alaska, in a very difficult environment, ways of using renewable sources of energy that can sustain us over time. These resources are finite, and so we have to look to the future. In the things that we do now, the approaches that we take now, and the research at places like the Cold Climate Housing Research Center that we do right now. The agenda is a very big one, and the time is very critical. We can't waste our time.